This is the last section before we take a unit exam next Wednesday, and I'm not planning on making a review video. You can just review the old videos. But if you have questions about things like Descartes' rule of sign, or the upper or lower bound theorem, or how to use synthetic division with an imaginary number, or maybe you don't know how to find the vertex of a parabola, or maybe you forgot how to complete the square, anything like that, submit a list of questions to me in class on Thursday, and I'll make answer everybody's questions video for the review for the test next Wednesday. In this section, you'll be solving polynomial and rational inequalities, and you'll be doing so either with a graph or with a sign chart. I'll show you both. So if I were to sketch this graph, and you have to think back to the little kid in front of the piano video, this graph has a 0 at +1, it has a 0 at -4, the -4 is a kiss, the +1 goes through, and it's not cubed like this because there's a negative sign right here. It's cubed like this. It flips it upside down. So it goes and kisses -4, comes back and shoots through +1. Now the questions you're going to be asked are inequalities. And this inequality is saying, where is the graph greater than 0? The graph is positive up here, and so this graph is greater than 0 in this entire blue section, except for it's not greater than 0 right there because it's actually equal to 0. So the graph is greater than 0 from -infinity to -4. It's also greater than 0 from -4 to 1. If you're answering the question, where is the graph less than 0, the graph is less than 0 right here in this section. So the graph is only negative, it's only below the line from 1 to infinity. So now we're going to look at the same problem with a sign chart. Actually, I'm not a huge fan of this method because I'm thinking if you already know how to graph, why not just graph? But the sign chart method looks like this. You've got -4 as a 0, and you've got +1 as a 0. And so what you're going to do is pick some numbers that are just off the edge of your chart, like put a number here and a number here and a number over here, and see what signs they come out to be. So if I put 2 into this equation, I'll have this dot represent 2. This would be a negative times a positive times a positive. And so everything out this way would come out negatives because a negative times 2 positives is a negative. And if I were to, let's say, change colors because it's fun and pick 0 to represent this number, and if I were to put 0 into the equation, I would get a negative times a negative times a positive. So that comes out positive. So all of these numbers would come out positive. So the graph would be positive in this area. And changing colors for fun again. If I were to put a point like -5 into the equation, so let's say this represents -5, this would be a negative times -5 minus 1, which is -6, times a positive. So at -5, that would make plus, so these will all be pluses. And then you could answer a question like, where is f of x less than 0? That would be this section, all the negative numbers. And you could say that would happen from 1 to infinity. I'm not a huge fan because I think if you just sketch the graph, here's a point 1, here's a point -4. -4 is a kiss, 1's a shoot through. I think you can see much more easily that the graph is positive in this red section and the graph is negative in the green section without making the sign chart and going through the trouble. You just have to be able to answer this question. Whether you create a sign chart or a graph is your choice. So for this function, it has a 0 at 2, so here's the positive 2. This right here is no solution. You can't square something, add 4, and get 0. So these are complex zeros. The other real zero is over here at negative 2. And I know when I count up my signs, this is an x to the first power, this is an x squared, and this is an x to the first power. So this function has a degree of 4. And if you think back to the little kid in front of the piano, a 4th degree problem is going to go up on both ends. So this problem is going to look like this. And the question for this problem is, where is this graph greater than or equal to 0? This graph is greater than or equal to 0 in the two sections where it's above the x-axis. This section right here, and this section right here. So if I answer that in limit notation, it's negative infinity to negative 2 union 2 to infinity, and I said greater than or equal to, so it actually can include these numbers, so I have to make hard brackets. So on the homework assignment, some of the problems are cubed, some of the problems are to the 4th power, some of the problems do not have real solutions. So if you're faced with a problem that's not all nice and all factored out, and it doesn't have real solutions, and it's too hard because it's cubed to the 4th power, just get out your calculator, use your calculator to find the zeros, and answer the questions based upon the graphs from the calculator rather than finding the zeros by hand. And I think it's 14 or 15 on the assignment where you start need to using your calculator to answer the questions. The next problem we're going to look at is a rational inequality. And what I'm showing you right now is sort of the wrong way to do it, but I want to show you why it's wrong, so we'll bust through this first. If you solve this problem like you did on last night's homework with the rational equations, you multiply by the common denominator, you get 5 times x minus 1 because the x plus 3's cancel, and you get 3 times x plus 3 because the x minus 1's cancel, and then you distribute and combine like terms. 5x minus 5 plus 3x plus 9 is less than 0, and so 8x plus 4 is less than 0, and so 8x is less than negative 4, and x is less than negative 1/2. That actually looks like really clean, nice algebra, and you're feeling good about yourself, like, oh yeah, I just got this problem, it was hard, and there's the answer. The problem is this is not the whole picture. If you're solving an irrational inequality, you need to think about the picture, not necessarily what you get, because kind of what happens is when you're doing this step right here, multiplying by x plus 3 times x minus 1, you are transforming the equations and you're eliminating parts of the equation. So although this will have zeros in the same spot, it won't have the same answers. So on any rational problem on today's homework, you're going to get out your calculator and you're going to graph this problem. And this problem has a vertical asymptote at negative 3. This problem has a vertical asymptote at positive 1. This graph does have a 0 at negative 1/2, like you found out. But when you sketch this graph on the calculator, it looks like this, and this, and this. And so if you're actually answering the real question, where is this graph less than 0? The answer is over here and right here. And that's not what solving the equation told you. So you have to be aware that solving a rational inequality is not always going to give you the real answer. The real answer to this problem is it's negative or below 0 from negative infinity to negative 3, and also from negative 1/2 to 1. The homework assignment has a few review problems from other chapters, and like I said, come with a list of questions for me to make a video for review for the test.